Hello, welcome to question 5. I'm not sure I mentioned the sponsors enough in the last video, but there they are. So, question 5. Mrs. Hintz gave her A-level class an algebra test, a calculus test, and a statistics test. Each of the 3 tests had a maximum score of 100. The scores of the 10 students who completed all 3 tests are shown in the table. The scatter diagram shows the scatter diagrams show the calculus score against the algebra score and the statistics score against the algebra score for the 10 students. So on the left-hand side, we can see calculus is probably a much better indicator. That looks like a stronger positive correlation than the statistics one. Okay, Mrs. Hintz expects a stronger positive correlation between algebra and calculus scores for her class than between algebra and statistics. In terms of correlation, what does stronger positive mean? So that means as one value increases, there is a greater chance that the other value will increase too. Okay, use appropriate statistical calculations to check that she is correct. So I am on the CG50, FX CG50, and when we're doing this part, we should have lots of practice of this. You're going to put the data into the table, so you're going to put 2 columns in. Once you've done that, you need to do F2 for calc. You need to do, that is the wrong one. I don't think it is F2 for calc actually. It's not graph, it's not test. Oh, it is calc, idiot. F3 for reg. How did I miss that? Honestly. F3 for reg. F1 to hit X. And then just F1 again. It's going to give us AX plus B. There we go. So on the one I'm looking at, we've got A, B, and R. R is the one that you want. So when we look at algebra onto calculus, we have an R value of about 0.9. And then when we're looking at algebra onto statistics, we have an R value of 0.77. So I'm then going to say she is correct. She is correct as A to C is closer to 1 than A to S. Okay, this is a big question. It's about 15 marks, so it might be a long video. Work out the equation of the regression line of C on A. So from that screen, that's the very same screen on the calculator. I've still got the data in here, which is great. You will be given an A and you'll be given a B. So the A for me is 0.7338 and the B is 3.1389. And the equation that I came up with is calculus equals 3.1. I don't know why I've put 3. It might be that in the mark scheme. But as you can see, this number would round to 3.14 plus 0.73a. I think, though, in the mark scheme, they do give you like a boundary. They'll give you a maximum and a minimum for these. So don't stress about that too much. But it does frustrate me that they don't often state to what decimal place they want these left to. So I would go with 2 whenever possible. Okay, draw your regression line onto the scatter diagram below. So what I did for this was I substituted in 20 and 100 so that I had decent values that weren't too far away from the graph. So for 20, I had 17.73, and for 100, 76.13. So that is just substituting it into that formula to get the coordinates. So 20 to 17.3, that would be very nearly 18. And then the 100 goes to there. And then we need to, lovely, that's good. There we are. That's my regression line. I'm pretty pleased with that. Okay, happy days. 2 more bits to go. Always looking at my notes. Right, 5C. Roy scored 51 in the statistics test. He was absent for the other 2 tests. The equation of the regression line of S on A is S equals 16.8 plus 0.55A. Use the equation of the regression line of S on A to estimate Roy's score in the algebra test. So this is really nice because it's just substituting into the equation. So his statistics score was 51. 16.8 plus 0.55a. So our first step is to subtract the 16.8, which gives me 34.2 equals 0.55a. And then we divide by 0.55, giving us 62.1818. And we can round that to 62. Okay, happy with that. The last part, and you can see bottom right now of the screen, it's 15 marks this question. Here are 2 methods to estimate Roy's score in the calculus test. Method 1 uses estimated algebra score with your equation of the regression line C on A. Method 2 uses statistics score with the equation of the regression line of C on S. This equation is Do these 2 methods give the same score? So, uses estimated algebra score with your equation of your regression line of C on A. So that's there. I'm just going to copy that. Can I just copy this? Oh, of course it's copied all of that. Well, there's 2 ways to do this. No, it's just right. We'll drag it down. It's fine. It's fine. Here we go. Come all the way down. All the way down to there. Then I can just start getting rid of these bits. Right. So that is C on A. Roy's calculus test. 2 ways to do this calculus test. So he got a statistics score of 51. And then we're going to put 62 into that equation. So C equals, and I'm going to label this method 1, 3.13 plus 0.73 lots of 62. Now, I don't like using this because this is a sort of extrapolated data. Or is it extrapolated? It's using something that was calculated and then recalculated. But, sorry, let's get my calculator working. 62 times by 0.73 plus 3.13. That gives us 48.39. So we would say that is 48. Now, method 2, using his statistics score was 51. So C equals 0.93 plus 0.934 times by 51. Have I got that correct? Yes, I have. 51 times by 0.934, add 0.93 is 48.564. And I'm going to suggest that that is also 48 because you could round it up, I suppose, but for the purposes of this, if we truncate it, we say we don't get the next mark, so you're at 49. And I'm happy with that. And yes, that does give us the same answer. Okay, that's question 5 done. Big 15 marker. Do study upon your regression lines. They tend to be worth quite a bit in these assessments, and you can really get yourself up the grades if you just understand how to use that calculator. I'll see you next time. Good luck in your exams.